It only takes 3% of the Gulf of Maine to heat every home and drive every car. Think about what we could do. We can minimize the impact on the fisheries, minimize the impact on the environment, and have these farms that you don't see from shore bringing us clean energy and creating thousands of jobs.
That was our guest on today's episode, Dr. Habib Dagher, touching on the future of offshore wind for Maine. Hello and welcome back to Maine Policy Matters, the official podcast of the Margaret Chase Smith Policy Center at the University of Maine, where we discuss the policy matters that are most important to Maine's people and why Maine policy matters at the local, state, and national levels. My name is Eric Miller, and I'll be your host. Today's episode is part one of a two-part series on Maine's offshore wind efforts. On this episode, we'll be interviewing Dr. Habib Dagher, the founding executive director of the University of Maine's Advanced Structurals and Composites Center. In 2 weeks, we'll be featuring a discussion with Celina Cunningham, Nicholas Lund, and Jack Shapiro on the environmental and policy implications of Maine's offshore wind efforts. Under Habib's leadership at the Advanced Structures and Composites Center, it has grown from 4 to 411 personnel and is now housed in a 100,000 square foot laboratory, the largest university-based research center in Maine. Habib is a world-leading advocate for developing sustainable infrastructure and energy systems which simultaneously optimize structures, materials, manufacturing, construction, and maintenance. Habib initiated a number of major research programs which have gained the Advanced Structures and Composites Center national and international recognition. Before my conversation with Habib, some context. About 80% of the U.S. electricity demands are located in coastal states. Fortunately, there is enough potential wind energy located offshore that would satisfy the entire country's energy usage by more than double. Unfortunately, nearly 80% of the offshore wind resource is located in deep water, which presents an engineering and economic challenge of capturing that wind energy for us to use back on shore. In 2019, Governor Janet Mills launched the Maine Offshore Wind Initiative to explore how to best position Maine to benefit from an industry expected to generate $1 trillion in global investment by 2040. The initiative aims to balance offshore wind with our state's maritime heritage, including fishing and natural resource protection. The University of Maine hasn't been on the sidelines, but is in a partnership with Maine Aquaventus to develop Volturn US, a floating concrete hull technology that works with wind turbines in water depths of 150 feet or more. University of Maine economist Todd Gabe estimates that the New England Aquaventus 1 project will produce nearly $200 million in total economic output and more than 1,500 Maine-based jobs, including jobs for construction and operations, as well as maintenance. While Maine is one of the leading states in offshore wind, other states and countries have been working to implement it as well. Rhode Island hosts the country's first offshore wind farm, which began operating off Block Island in 2016. In 2020, Rhode Island's Governor Gina Raimondo announced that she would sign an executive order increasing the state's renewable energy resources with the goal of 100% of its electricity needs being met through clean energy resources by 2030. In 2022, New Jersey's Governor Phil Murphy signed an executive order increasing the state's offshore wind goal by nearly 50% to 11,000 megawatts by 2040. Globally, the European Union has been a leader in offshore wind. The EU has helped develop wind power through policies and investments in collaboration with European companies. The first offshore wind farm was installed in Denmark back in 1991. Currently, the EU is a global leader in the manufacturing of key wind turbine components, as well as in the foundations and cables industry. Almost half of the active companies in the wind sector, both onshore and offshore, are headquartered in the EU. While clean, renewable energy generation goals have been set, there have been setbacks due to regional and international economic phenomena. New York, for example, has lost multiple offshore wind projects due to inflation and supply chain issues, and consequently threatened their decarbonization goals. Our discussions over the next couple of episodes will unpack why and how offshore wind can help Maine have clean power. Hello, Habib. Thank you for joining us today.
Great to be with you, Eric.
Can you give us a brief background of offshore wind energy in Maine?
Yes, offshore wind energy was born in Maine close to 12 years ago when energy prices went up through the roof, if you recall. We were paying $4 a gallon at the time for gasoline and heating oil. So there's a big crisis in the state of Maine in terms of how do we heat homes. The average family in Maine at the time was paying close to 20% of its income just for energy. That's heating and gasoline. And so there's a crisis in the state. $4 a gallon back then was more like a $7 or $8 a gallon today. So the crisis is how do we keep people's home heated and how do we keep energy prices stabilized? So at the time, the leadership of the state came to the university and said, what do we do now? How do we move forward? So we started looking at a variety of options for Maine to produce its own energy locally using renewable resources to address climate change as well. So we looked at everything under the sun, including hydro. We looked at solar, of course. We looked at offshore wind. We looked at tidal energy, wave energy devices, biomass. So we looked at everything possible. And the bottom line, what we learned is that the biggest opportunity the state of Maine has is offshore wind and deep water offshore wind. That's when we started digging deeper into that opportunity. At the time, Governor Baldacci put together a bipartisan task force to put an offshore wind plant for the state of Maine. So the task force was very bipartisan and stated a goal of 5 gigawatts of offshore wind for the state of Maine. But Maine has very deep waters, so you can't fix the turbines to the seabed. So you have to float the turbines. And that technology at the time really didn't exist. Floating a turbine is almost like having a boat that holds up a turbine, in essence, if you think of it that way. And you would build those dockside and tow them out to sea. Because the technology didn't exist at the time, the university embarked on the challenge to figure out how to design floating turbines that could be built in Maine and that could allow us to harness this great resource that we have at the time. And the state of Maine put a bond together on the ballot asking the people of Maine, do you want to invest $11 million to help drive this technology forward? And the people of Maine voted. And they said yes. So the state of Maine provided $11 million for the university based on this vote to advanced floating offshore wind technology research. And that occurred close to a decade ago. And since then, we developed technologies. And in 2013, we deployed the first grid-connected floating offshore wind turbine off the US coast. It was a 1:8 scale version of our current technology, and it was built in our lab at the University of Maine. We worked with Chimbro at the time, and we deployed it from Brewer, Maine, towed it down the Penobscot River, and moored it off Castine, connected to the grid. And that was the very first time offshore wind electrons were put onto the US grid. It happened here in Maine. And that technology, that turbine, the purpose of that was to see how it performs with winds and waves and large 50-year and 500-year storms. And it did extremely well. So that's a bit of the history. On a parallel track where the technology is being developed, the state of Maine passed a number of bills to move offshore wind forward. The first one was a little over a decade ago. It was passed in a complete bipartisan fashion. Was the Senate and the House in Maine voted unanimously to move offshore wind forward with only one abstention. So that was a decade ago, right? And so there's been a strong support to tap into this vast energy resource, create jobs in Maine, and help protect the environment and so forth. So since then, the University of Maine won an award from the U.S. Department of Energy to build a bigger version of this unit. We're busy working on that right now, and we have 2 demonstration projects that we plan to move forward with. One will be in Castine again, and it's a bigger unit, about 225 kilowatt unit and an improved design. And then later on, we have another project off Monhegan Island that we've been working on. And the state of Maine also put together a Maine research array proposal that will have 10 to 12, 15 megawatt units that will be deployed also 20 miles south of Monhegan Island. The test site, and it's called the Maine Research Array. So if you think about what's going to happen for the rest of the decades, there's a number of small projects to help us dip our toe in the water in the state of Maine, in essence, understand the technology implications, but also the environmental, ecological, as well as implications to the fisheries in the state of Maine, which are very important to us. So we like to call the plan 110-100. Let's put one in the water first, and then when we get really better at it, and learn a lot from that, and put 10 more and understand the impact of these projects on the environment and the fisheries, as well as develop the workforce to build them. And then once we do the 10, which will be near the end of the decade, then we move on in the next decade and build, hopefully, commercial farms. These farms would be beyond the horizon, that you won't be able to see them from shore. That's the goal. They'll be in 25 plus miles, maybe 30 miles offshore or 35 miles offshore. And because of the curvature of the Earth, of course, we're not going to see them. This year or next year, the Bureau of Ocean Energy Management, which is a part of the federal government, is going to have a lease auction for commercial wind farms in the Gulf of Maine. And that's an effort that both Maine, New Hampshire, and Massachusetts are collaborating on, because the Gulf of Maine stretches all the way to Massachusetts. So this lease auction is going to basically lease areas in the Gulf of Maine for larger commercial scale farms. Also, the state legislature and the governor signed into law a bill this last summer to acquire 3,000 megawatts of offshore wind capacity here in the state of Maine by 2040. That would be floating wind turbines as well. That would be roughly a $9 to $10 billion construction project that would create thousands of jobs here in the state of Maine. And that would require, of course, a construction of a port facility specifically tailored to fabricate these units and get them out there. So there's opportunities to create thousands of jobs. The other thing that's really important is to put in perspective to how much offshore wind we have in Maine. So in the Gulf of Maine, there's enough offshore wind capacity is equivalent to 156 gigawatts of offshore wind capacity within 50 miles of the Gulf of Maine. What does that mean? A gigawatt is roughly a good-sized nuclear power plant. So think of it that we have the equivalent of 156 nuclear power plants of offshore wind capacity just blowing off of our coasts. So the challenge is, how do we bring that energy back to shore to reduce our environmental footprint, to create the jobs and keep our energy dollars in Maine? And that's really the challenge that we've, for the last almost decade and a half, that we've been working on. That's a bit of the history, if you wish, of how we got here. And so looking forward, looking ahead, the next big phase for us from a research perspective is we're going to have a turbine in the water by the end of this year, the 225 kilowatt unit. But at the same time, the BOEM lease auction that's going to occur as well.
That's great. I don't know what I'm more impressed by, the idea that seems outlandish and seems like such an overwhelming technological challenge that is developing offshore wind and deploying it, or political consensus. And it's hard to imagine 10 years ago. But in all seriousness, it really is amazing how this idea of floating offshore wind miles off the shore coastlines of Maine, it seemed like such a wild idea that it now seems not only feasible, but there's proof of concept in moving forward with it. And there's been buy-in. That is amazing. And I imagine you've learned a ton over this time that you've been working on it. But in the national discourse, it tends to get a little bit messier. What are some of the most common misconceptions about offshore wind energy?
Yeah, certainly. I think you put it in your questions, in your comments, you said technological issues as well as societal and political and other issues. The big thing is on the technology side is we've made a lot of progress, and the floating wind technology has been tried now. Fixed bottom technology, it's been built around the world. There's thousands of turbines across the world right now. They're fixed bottom offshore wind turbines. The European Union has major goals to use offshore wind as a key part of its energy future. So things have moved quite a bit from that perspective. From the technology side, I think we need to have the ability to have some ports that can build these units and get them out there and maintain them. That's really important. The turbines are getting bigger and bigger technologically. So the biggest turbines right now are near 20 megawatts. To put that in perspective, each blade is more than 1 1/3 football field, just one blade. So the rotor diameter is 2.5 football fields. So these are big units, and they exist today and they're being used. But the 15 megawatt units are becoming more common right now as we speak. The 20 megawatts is the next generation. So these turbines, if you think of just a 120 megawatt turbine alone, is able to produce enough energy for 10,000 US homes. Just one turbine. Okay, that turbine are getting larger, and the technology has advanced a lot. So there's still some challenges in terms of durability and moorings and anchors and so on and so forth, and trying to minimize those costs. Delivering the power back to the grid also requires high voltage. Farms are 30 or 40 miles offshore, high voltage direct current systems that need to be installed. These are certainly next generation technologies as well, particularly as we use them with offshore wind. I'm very optimistic that all of those questions are technical questions are things that we can answer over the next 5 years, so that when 2030 comes in and we're going to build commercial farms, we would be ready technically. The state of Maine also, we've been hosting a conference on offshore wind every year on floating wind. It's called the American Floating Offshore Wind Technology Summit. It'll be the last week of September this year in Portland, Maine. And we've had really good success. Near 500 people came last year. So there's a lot of interest in the technology. And so on the technology side, we're doing well. For the negatives that said you can't float a turbine, it's not going to survive a storm, and so on and so forth. And those questions are behind us. I don't think there's any issue there. There are a number of floating demonstration projects across the globe, and we have put some out there and proven that it does work. The other question that people ask on a technical side is you can't run everything on wind and solar because, of course, wind and solar are intermittent resources, right? They're going to be there all the time. And that's true. They're intermittent. But I think by having both wind and solar and hydro together, we can minimize, if you wish, disruptions. For example, at nighttime, the sun is not shining, so we can't have solar energy. But the wind could be blowing off the coast of Maine at that time. That's an example of where synergies between wind and solar can really help us reduce the uncertainties by having multiple sources of renewables. Plus, battery technology is moving forward significantly right now, advancing significantly, and Maine is installing some very major battery systems as well as across the world. And then electric vehicles in the future also will become storage facilities for offshore wind energy and others. So when you have an electric vehicle, you can be charging it when you're not using it. And the grid can actually, in the future, you can sell back energy to the grid if you have excess energy in your car. And that's happening already. So having a large system of distributed batteries in cars, as well as larger fixed location systems, could also deal with some of these issues. So there are solutions for these issues and of intermittency by diversifying the renewable resources because they come in at different times. So, and by supplementing that with fixed batteries or mobile batteries like cars. So those are some of the things that we hear a lot about. And of course, there could be some backup as well when natural gas power plants could stay behind and are used only as needed, if in essence, to help stabilize the grid. And in Maine, of course, we can also be using some of the hydro resource we have to help stabilize the grid and even potentially collaborate regionally with Canada and the Eastern Canadian provinces where their hydro resources and our offshore resources could work together. So there's ways to get around some of these issues as we work together regionally. So that's on the technology side, some of the concerns and what we hear. So, and the other set of concerns, of course, are, as you said, societal and political and so forth. So on the societal side, it's really visual impacts. People say, I don't want to see them. And that we recognize that it's an important issue to a lot of people. But the solution is put them farther from shore, okay? And that's floating technology allows us to do that. So when they're 30 miles offshore, nobody's going to know they're there, and because of the curvature of the Earth. So we have answers to that. And the other thing that's really very interesting is by putting turbines farther from shore, the wind gets to be better, actually. The turbines are more efficient farther offshore anyway. So putting them 30 miles or 35 miles offshore is feasible, and the technology exists to do so. The other issues are environmental and ecological issues, very important issues that we hear about. What is the impact of these turbines on the fish, as well as the mammals and the whales, as well as the birds? And that's very important issues. Part of any plan need to make sure that we have the science behind answering all the questions. So that's another set of questions. We've collected a lot of information, not only in Maine, but throughout the world on these offshore wind farms. So the first offshore wind farm was put in Europe back in 1991. So we've had a long history. We have 3 decades right now of information on some of these offshore installations. And Europe is moving fast ahead with offshore wind, even as they've built up thousands of turbines already. So there's a lot of information that we've learned from in terms of the European experience, impact on ecology. But at the same time, we need to recognize that we have different ecology in the Gulf of Maine, and we need to really make sure we have the data on the specific ecology of the Gulf of Maine, the specific types of birds and bats and fish and mammals that exist in the Gulf of Maine. And so these questions need to be answered. And the state of Maine has put together a task force and a roadmap for answering some of these questions. So there's a lot of work going on to do that. And at the same time, on a parallel track, some of the same issues are what are the impacts of these offshore wind turbines on the fisheries? And that's very important for all of us. The goal is how do we minimize the impact on the fisheries? And one answer to that is put them really far away from shore where we really don't have a lot of people fishing. So that's one of the solutions. And we know, for example, Lobster Area Management 1 is where the majority of the fisheries take place in the Gulf of Maine and the Maine fisheries. And the latest work that's been done, and thanks to the state efforts as well as the congressional delegation efforts, the Bureau of Ocean Energy Management is not going to look for lease auctions in Lobster Area Management 1. We're going to stay out of it. So they're going to go further behind it and so forth. So that addresses one of the biggest questions the fisheries have. So because floating turbines can go almost anywhere, you can put them far enough away that where you really are minimizing the impact on the fisheries. And that's happening already. So some of these things are being taken into account, but additional research is taking place to see what the impact, even though these farms could be 30 or 35 miles offshore, let's figure out what the impact is anyway on the fisheries, specific species that exist in the Gulf of Maine, under and above the water. And the state is doing tremendous work to try to move that forward through the research task force they've put together. So yes, there are a lot of questions, but as you see, there's a lot of good people doing a lot of hard work to answer those questions.
Yeah, it's rare to have the answer to a concern to be an actual positive feedback loop in the question of the grid, for instance, where it can be a complementary energy source, not necessarily one that leaves people in rolling blackouts or having some sort of concern about the reliability of their home, their safety, shelter. And so you got to some of the economic questions already. And of course, there have been some major programs passed at the federal level to facilitate the technological development and deployment of offshore wind energy. What are some of the national and state of Maine goals related to offshore wind? How are your team at the University of Maine and the state of Maine leveraging the Inflation Reduction Act or bipartisan infrastructure law federal programs? And how are these federal subsidies transformative for offshore wind?
That's a very good question. The Inflation Reduction Act has a number of components within it that incentivize the development of renewable energy and other, not only just offshore wind, but within the offshore wind space specifically, there's a 30% tax credit that you could get if you place a farm like that, which help reduce the cost of offshore wind to the consumers. And on top of that, there's a 10% additional tax credit based on local content. If you can meet certain local content requirements, you get an extra 10% tax credit. So those two incentives are some of the biggest incentives within the Inflation Reduction Act that can be used to help start this technology, both floating wind and fixed bottom wind. We'll take advantage of that. That will also help incentivize the production of components in Maine and the United States. So if you're going to get a 10% extra tax incentive by putting a plant in Maine to make turbines or in the US, that's going to attract a lot of investment to do that rather than do it overseas. That's the clear advantage that the Inflation Reduction Act has created. In addition to that, the federal government has declared floating wind as the fifth U.S. Earthshot. In other words, it's been declared as a key technology for the U.S. to meet its climate goals and its energy goals. And that was a big deal when you look at this. Started in Maine a decade and a half ago, and people questioned how this is feasible. But today, here we are with the federal government declaring this technology as a U.S. Earthshot. It's called the Windshot. It's very satisfying to see that the federal government also now has heard all of this and really wants to move this to the national level. So the federal government has a goal of 30 gigawatts of offshore wind capacity, a fixed bottom capacity by 2030. To put that in perspective, as I said earlier, a gigawatt is a good nuclear power plant. It's like, okay, we're going to build 30 nuclear power plants worth of wind between now and 2030. So that's one of the federal goals. That's for fixed bottom wind. But there's, in addition to that, as part of the Windshot, 15 gigawatt by 2035 of floating wind. So there's a floating wind component of that as well. When you look at that together, there's very significant national goals, both for fixed and for floating, that exist right now. Turning back to Maine, what are the goals? The state of Maine has already, Governor Mills signed into law a bill passed in a bipartisan fashion to acquire 3,000 megawatts of offshore wind capacity by 2030. So Maine has a goal to have 3,000 megawatt of floating wind by 2040, and that's a big deal. One of those should be awarded before the end of the decade. So it's going to happen very soon where we start doing that and transforming our energy system using offshore wind. So these are the national goals and some of the state goals that currently exist.
That's amazing to have the up and coming of an energy resource to be considered among the echelon of top energy resources for the country when it seems like there's been such a focus on fossil fuels for so long. So we have discussed some of the federal incentives and to deploy the technology, and we talked about some of the social factors already. But when it comes to the consumer's pocketbook, I'm sure people are quite keen to learn how exactly it will affect them, as 80% of the residential load is handled by Central Maine Power, and the rate for those residents will be 22.61 cents per kilowatt hour in 2024, which is down from 28 cents in 2023, but that is still 6 cents higher than the residential national average of 16.21 cents. What impact will offshore wind have on electricity distribution, transmission, and standard offer rates?
That's a very, very tough question. To answer the question correctly, one needs to look at this as that fossil fuel prices aren't going to go down either in the long run. Most analysts believe that fossil fuel costs will continue to grow, and they have. If you look over the last decade or so, our energy prices in Maine have kept going up because essentially natural gas prices kept going up. We're so dependent on natural gas right now, and not only in Maine, but throughout New England. We're more than 50% reliant on natural gas power plants. So one of the question is, what's going to happen to natural gas prices over the next 10 or 20 years? And what does that mean to our pocketbook? More likely than not, they're going to go north versus south. So that's one piece to look at. So those numbers that you just quoted could potentially continue to grow. So now, when you look back at offshore wind capacity, and you start asking yourself, can we compete with natural gas prices with offshore wind? And the answer is it is feasible to do that, but we have to scale up the technology. So we can't just do 2 or 3 turbines and call it good, because that's going to be very expensive. So scaling up the technology is really key to drive the cost down, and building the infrastructure to deploy the energy, which is really the port facilities. So we need to have port facilities capable of producing hulls of this scale. Each hull is like a ship. 1,000 megawatt farm is going to have, if we use 20 megawatt units, is going to have 50 of these ships, just 1,000 megawatt farms. So think about if somebody called up Beth Ironworks tomorrow and said, I want to produce 50 ships and I need them in the next 2 years. Okay. But how are you going to do that? Okay. And so we need infrastructure to do that. And the state of Maine and other states have been looking at improving their port facilities. And the port facilities needed for floating wind are different, because in a floating wind farm, you're actually building ships, you're building hulls, and you don't do that for fixed bottom turbines. So there's a lot more job opportunities with floating wind because you can produce the hulls, and you need shipyards to do that. So if we can build and make the investment we need in these facilities, that will scale up the technology. The US Earthshot that I just told you about has a goal by 2035 for offshore wind capacity to be near 5 cents a kilowatt hours in last year's dollars. So of course, that's 5 cents in last year's dollars. So in 2035, that's going to be quite a bit more because of the inflation. But in last year's dollars, that's the goal, is to get down 5 cents a kilowatt hour. It's a national goal. I think it's an ambitious goal to do that. But initially, it's going to be quite a bit higher than that. But as we scale up the technology and essentially create the 4 factories for these hulls that we need to do that, we're going to drive the cost down. And many analysts believe they'll be competitive with the rising fossil fuel-based pricing, if you wish. Another piece of this that we need to look at, in addition to the comparing dollars to dollars, the impact on climate and climate change and the cost of climate change really need to be factored in. We had a rude awakening in Maine here over the last week to 2 weeks with 2 back-to-back storms that created havoc on the coast of Maine. And this pricing, if you wish, of continuing to use fossil fuels isn't priced into the cost of that society is paying right now. And so if you start pricing in the true cost of fossil fuels, the picture for offshore wind and the cost of society for offshore wind would even become more competitive. So if you do that as well. So I am optimistic that if we scale up this technology and build the ports we need, we're going to have pricing that will compete very well with natural gas and other fossil fuels with offshore wind. And to layer on top of that the societal costs of climate change that we're already paying right now, there's no question that offshore wind will be the least cost to society overall.
And it's rare that you can have an energy source that goes down in price and increase scale and length of use. With depletable resources, of course, then you need to keep moving around to capture more energy, and the cost of capturing energy is different, whereas offshore wind development got that scaling that's favorable to keep going. So we've touched on some of the social and economic factors already, and I think a question for folks that was brought to light in the CMP corridor vote, there's quite a bit of concern about how there was a lot of sacrifice to Mainers for the benefit of people from out of state. Will the electricity generated by Maine's offshore wind solely be distributed in Maine, or will it be shared with its neighbors in Boston or New York?
I think it's very difficult to know because we haven't really even located where those farms are going to go yet in the Gulf of Maine. The Bureau of Ocean Energy Management is going to be putting a lease auction this year or next, and then we're going to find out where those farms are going to go. And depending where those farms go in the Gulf of Maine, the Gulf of Maine stretches all the way to Massachusetts, as you know. And if those farms are built near Massachusetts in the Gulf of Maine, then I would expect that some of that power will go directly to Massachusetts. If they're built more north of our coast, it would make more sense to bring the power to Maine. And there are opportunities to bring the power to Maine. There's existing facilities currently that can absorb a lot of new energy. I can think of two places right now. If you look at the Wiscasset nuclear power facility in Maine, that was almost an 800 megawatt plant now that has its electrical infrastructure as well that distributes in Maine. And if we brought an offshore 800 megawatt cable to Wiscasset, then certainly, of course, I can't predict if this is going to happen or not, but there's an opportunity. And if a project decides to do that, that's leased over the next few years, then most of that energy will be used in Maine because of where that network is. Another opportunity in Maine is in Cousins Island. Cousins Island has, as you know, a coal-fired power plant. That's, if you're in Portland and you look up on Casco Bay and you're facing Casco Bay and look to your left here, you'll see the smokestack from the Cousins Island facility. And that facility uses coal, and it only is used a little bit in the year. Maybe we use it for a couple of weeks or less per year. There's an opportunity to bring offshore wind power to that area because that plant isn't used all the time. And offshore wind power could be distributed in Maine through that same existing electrical infrastructure. So if a plant does get built, an offshore wind plant that will go to Cousins Island, a lot of that energy will be used in Maine. So the answer is, it depends on where those plants get placed in the Gulf of Maine, Eric, but there's opportunities for this energy to be used in Maine.
Thank you. The zoning question is one that is always out there. Thank you again for joining us today. I've learned so much in this brief conversation. Do you have anything you'd like to add regarding offshore wind energy that we haven't covered already?
Yeah, I think one of the major advantages of offshore wind for the state of Maine, other than the fact that it exists right off of our coast, is that offshore wind, the wind speed in the Gulf of Maine, the wind energy speed increases in the wintertime. And the way it works is if the wind speed doubles, then the energy you can extract is multiplied by the factor of 8. So basically, it goes by the cube of the wind speed. Offshore wind turbine in the summer in the Gulf of Maine versus the winter. In the winter, it could produce in the winter month 8 times as much energy it produces in the summer month. And that makes it very good for us because we need to heat our homes in the wintertime. So the offshore wind energy is perfectly timed, if you wish, to our heating needs in the state of Maine. If we were to use heat pumps and have offshore wind energy, we could be heating our homes most of the time without having to rely on fossil fuels. That's one advantage we haven't talked about. The other thing I'd like to put on the table is how much offshore wind energy does it take to heat every home in Maine and drive every car in Maine? Of course, we're not going to do it that way. No one wants to just use offshore wind to drive. But just as a hypothetical question, just to give you a sense. Well, it just so turns out we need about 5 gigawatts of offshore wind capacity. Remember, I said there's 156 gigawatts of offshore wind capacity in the Gulf of Maine? 5 divided by 156 is 3%. It's very important to point out that if we just harness 3% of offshore wind of the surface area of the Gulf of Maine, we can heat every home and drive every car. Of course, we're not planning to do that, but this gives you a sense that how much energy there is out there in the Gulf of Maine. So, and the question really is, which 3% are we going to pick? Okay. And if we can keep that 3% of that 50-mile area further out, 30 or 40 miles offshore, and figure out where 3% makes sense, it only takes 3% of the Gulf of Maine to heat every home and drive every car. Think about what we could do. We can minimize the impact on the fisheries, minimize the impact on the environment, and have these farms that you don't see from shore bringing us clean energy and creating thousands of jobs.
That's amazing. It's rare to get uplifting environmental news looking toward the future in regard to how we can feasibly address the grand challenge that is climate change. And so I really appreciate you for that, as well as all of the knowledge that you have brought to this episode. We're really grateful for that and for you taking the time to join us today.
Thank you, Eric. It's a great pleasure to be with you. Hopefully we'll have more of those together as time progresses.
You can find links for more information in the show notes of this episode. Thank you, listener, for joining us today. This is Eric Miller, and I'll see you next time.